Warning: the following content has a preponderance of Membean lexicon and has a few scenes of comic humor and carnage. Please proceed at your own detriment.
What is light?
Your face! Your face!
What is light?
Anything but your face.
To describe it more accurately,
Your face!
Guys, stop digressing from the topic.
that's a Membean word.
Okay, mate, stop being so arbitrary.
That's also a Membean word.
What is light?
Light is a transfusion of energy that travels in waves.
Especially through your face.
Wait, is that a Membean word?
Is that a Membean word?
A few moments later.
Fine, I'll stop.
What is light?
Light is a transfusion of energy that travels in waves.
These waves are part of the electromagnetic spectrum.
The electromagnetic spectrum is actually energy in the form of electromagnetic radiation.
The light is made up of little granules called photons.
What the heck is a photon?
Is that a Membean word I hear?
No, sir.
That sentence is devoid of Membean words.
Fine, I'll condone this for the entire video.
A few moments later.
Enough choreography. You can exalt in other ways too, you know?
Guys, we have to stop digressing from the topic.
Oh yeah, photons are the rudimentary particles that make up light.
Weren't we supposed to be presenting about, waves? Not, particles?
Oh yeah, light waves. Light waves, like always, have a crests and neutrons.
The distance between two adjacent crests or trows is discerned as the wavelength.
Distance from the crest or trough to the center of the wave is discerned as the amplitude.
The wavelength determines how much frequency is withheld in the wave.
The larger the wavelength, the lesser the frequency in the wave.
The amplitude determines how much energy is in the wave.
The more grandiose the amplitude, the more energy is withheld in the wave.
That seems rational. But what does light actually derive from?
Your face!
No, sir, they actually derive from the electrons.
You see, when an electron is in an ecstatic state, it emits radiation in the form of light waves and becomes dormant.
Similarly, when light surges into a dormant electron, the electron becomes ecstatic again.
Contingent on what frequency the radiation is emanated and absorbed is a specific color.
The movement of the electrons causes an oscillating magnetic field, which in turn generates a perpendicular electric field that is intertwined.
If the light wave is not potent enough to transmute the state of the electron, it will be reflected.
Now, let's talk about ray tracing.
What the heck is ray tracing?
It is a procedure for rendering graphics.
What the heck is rendering?
It is the process of converting 3D objects into 2D graphics.
In a nutshell, it is a way of making your loathsome faces look grandiose on a screen.
That moment when you agree with fish.
Guys, stop deviating off topic, and it would actually make your face look more grotesque because the procedure makes the graphics more corporeal. So it would show the verity of your face.
Fine. Basically, it imagines a virtual camera, looking at the scene as it unfolds. It envisions a light source, the many light rays emanating, and how the light gets disseminated throughout the scene, an angle. The path of each ray is traced back to the camera. It also realistically depicts shadows, the refraction of light, and the diffraction of light.
Before ray tracing, there were two procedures, rasterization and radiosity. Rasterization is often used in video games as it can create good graphics in real time. The rasterizer basically looks at the profusion of triangles in the scene and determines which can be observed in the current perspective. The graphics engine then scrutinizes the light sources and other environmental details to establish the light and color of the triangles.
Rasterization is good, but as you can see from the clips being played, ray tracing supersedes rasterization. Now let's talk about radiosity. Radiosity is a procedure that focuses on global lighting and how light gets diffused throughout the scene. It is optimal for creating natural shading.
Ray tracing is really good for CGI movies, as they don't have to render in real time. Look at this frame from Toy Story 3 as it is being rendered. This frame took 16 hours to render completely. Evidently, this is not optimal for games, as the graphics need to be rendered at about 60 frames per second.
To simplify this, GPU, or Graphics Processing Unit, developers such as NVIDIA are creating their RTX technology so that the ray tracing engine only analyzes the most salient light rays in the scene so that the ray tracing can run at real time. Normal ray tracing analyzes almost every single light ray.
So ray tracing is pretty lit.
Haha, very punny.